So now in this class we are going to learn what is the process of the junction analysis or node analysis here. Now initially identify the junction. Junction means it is a point where three or more branches will meet or three or more elements will meet, anyone. So it is a point where three or more elements will meet. And node, it is a point where two or more elements will meet. So, but we are going for identify junction. Why? Because whenever we are going for node, more number of equations will come here. So to decrease the more number of equations to very lesser equations here, so we are going for junction here. Why? Because by going for junction analysis here, my equations will decrease here. Then my solution will be very simple. Then make any one junction as ground. For suppose I identified around four junctions here. Then I will make any one junction as ground here. Then I will assign the junction voltage for remaining junctions here. Like a policeman at a junction here, I will keep one junction voltage for remaining junctions here, like VA, VB, VC. Then assign current directions for every branch. For every branch, I want to assign current directions here. In which direction current is flowing here. And branch means, what is the meaning of branch here? It is between two junctions here. For every two junctions here, we are having one branch here. Then apply KCL for junction and solve the junction voltage. And once the junction voltages will come here, I can find the branch current. That is the main purpose of this one. Then initially I'm solving a small problem here by taking all the 5 points here. Now what is the point number one? Initially identify the junction. So I know, for suppose when I will go for this point here, I'm having only, so initially identify the junction and node. I know this is it is a point where two elements came here. As two elements came here, it is a node. But coming for this one, here three elements came. So three or more elements, junction, and it is also a node. But I'm writing as a junction here. And again here two elements came, so node. But whereas here all these points are having same potential here, so three wires are coming here, so it is a junction. Then the point number two will be make any one junction as ground here. So I can make this junction as ground here. So I can make this junction as a ground. I'm making this one as a ground here. So this is a ground, means it is a 0 volt. Okay, so it is a 0 volt. So it is a 0 volt. Then I will make this one as junction here. It is a ground. Then how many junctions we are having here? Then point number three. The point number three will be assign junction voltage. So I never care about nodes. So I'm not going for node here. Why? Because when I'm going for node, more number of equations will come here. So I'm going for junction. So point number three is assign junction voltage for every junction here. So I'm having only one junction here because one is ground means 0. So I'm having only one junction here, so I will assign a VA at junction voltage. That is the point number 3. Then coming for point number 4, assign branch current. So I said the branch current means a branch means between two junctions here. So then branch current will be between two junctions here. Then I want to assign between two junctions here one branch here, some branch currents here. So here the branch current will be, how many branch currents will come here? Three branch currents. Why? Because we know the branch means between two junctions here. I know it is the VA is one junction here and ground is one junction here. So from VA to junction, one branch will come and one more branch will come and one more branch will come here. So three branches will come here. So I will make one branch. This is one branch current, and so something like branch current I1, and this is one more branch current, so something like I2, and this one is one more branch current. This is a I3, because I know the branch current will be between two junctions here. So I1 is a branch current for junction VA and ground, and I2 will be the branch current for junction VA to ground, and I3 will be the one more branch current from VA to ground. So then at last the point number 5 is apply KCL. So we can apply KCL. So if you apply KCL at junction for remaining junctions here. So I know here junction is only VA. Then I will apply KCL. If I will apply KCL, we know if I will place my pen here at VA, all currents are leaving. As all currents are leaving here, then I can say I1 I1 plus I2 plus I3 should be 0. So should be 0. That is a KCL for VA. Then apply all the formulas here. I given some formulas for you. So apply all the formulas here. Uh, so now if you apply KCL at VA, all currents are leaving here. I1 plus I2 plus I3. Then we know we can apply the formulas. I1, what is I1? I1 is equal to VA minus 0, VA minus 0, difference of potentials here. So I1 is given as VA minus 0 and one more minus 5. Why? Because minus 10, it is a VA minus 10 by 0. So by R. So here what is R? R will be 5. So very simple. How this formula came? I1 is given as VA. So VA minus 0. So I1 is given as difference of potentials here, VA minus 0. But we are having one source here, plus 2 minus. As current is coming from plus 2 minus 10 by 5. That is a I1. Then coming for I2. I2 is given as VA minus 0 by 10 because difference of two potentials here. And I3 VA minus 0 minus 5 by 2. In this way, write all the formulas here. So I2 is equal to VA minus 0 by 10 by 10. Then I3. So I3 is equal to VA minus so VA minus 0 and minus 5 by 2. So now we can keep all these equations at this KCL here. Okay, very simple. I will keep all these equations here so we can complete within 2 minutes. So VA minus 10 by 5, VA minus 10 by 5, then plus VA minus 10. So VA by 10, VA by 10. Then coming for plus again, then again plus VA minus 5 by 2. So VA minus 5 divided by 2. So divided by 2 should be 0. That is, then we can find what is IA, what is a VA. So make a VA as common here. By making VA as common, so I know 1 by 5, 1 by 5 is given as 0.2 plus 1 by 10, that is given as 0.1. I will make VA as common here from all. Then 1 by 2 is given as 0.5. So my brackets close here, and minus 10 by minus 10 by 5 will be 2, and minus 5 by 2 will be 2.5. Should be 0. Then upon finding the answer, so so 0.2 plus 0.1 plus 0.5, 0.8, then 2 plus 2.5, 4.5 divided by 0.8. So I can, at last we can find VA, VA is equal to 4.5 by 0.8, that is given as 5.62 625 volt. In this way, we can find the voltage. That is the junction voltage. And once junction voltage will come here, I can find all the branch currents here. Once junction voltage will come here, I can find all the branch currents here. Now I can find I1. Very simple. I1 is given as VA minus 10 by 5. So 5.625 minus 10 by 5. Something negative answer will come here. And whenever negative answer will come here, for suppose here, once I will find I1, I1 is given as I1 is equal to VA. So VA 5.625 minus 10. So divided by 5, I got minus 0.875 ampere. That is I1. Then coming for I2. I2 will be VA means 5.625, 5.625 divided by 10. Answer will be 0.5625 ampere. Then coming for I3. Coming for I3. I3 will be VA minus 5 by 2. So what is the VA? VA means 5.625 minus 5 divided by 2. So answer will be 0.3125 ampere. And here negative sign implies, here the negative sign implies here, the I1 is minus 0.875, negative sign implies here, the branch current which I taken here is a wrong. There's no problem here because in the exam, they will ask you only magnitude. They never consider plus and minus here. So, but the minus sign will indicates the branch current which I taken in this way is a wrong here. If I taken like this, then answer will be plus here. So there is no problem for minus or plus. In this manner, by using node analysis here, we can able to find different branch currents here. But initially, the process will be identify the junction and make any one junction as ground here, then assign the junction voltage here, and then assign branch currents here, then apply KCL and find VA or something junction voltage here. Then you can find all the branch currents. Okay, so thanks.